All right, so here's this problem that you wanted me to talk to you about. So the curve in black is the function that's given to you, and I just wanted to give you a visual of what the parent function looks like, which is the y equals square root of x function, and it's given in the blue. And basically I found the square root of 0, of 1, and at 4 to help me draw that curve. So we can see transformation has occurred. And what I tell students most of the time is to use the origin as your reference point, basically, of transformation to see what has happened from there to where it ended up at. Okay, so here's where it started, and here's where it ended. So at a glance, we can tell that the graph has moved over 4 units to the right, and then that point went up 3 units. Okay, and then we notice that the blue graph kind of is now pointing in the other direction. Okay, and when that happens, it basically flipped, or better word, reflected over the y-axis. Okay, because it's pointing in the other direction. As far as points, whether it's stretched or not, that's really hard to tell graphically. And I don't think that that's what they would ever do to you guys on a test. But for the most part, with those, you would just use picking values and plugging them in to make sure that they are correct, okay? So let's look at the first option that they gave us. So the first option they gave us was y equals 4 minus x square root, so square root of 4 minus x, and then plus 3. Now, what we want to do is, well, right off the bat, students don't have much of a problem here. They realize, okay, I know that this is up 3. The numbers that add or subtract on the outside of the graph will always be your vertical shift, okay? So that automatically, of your 4 answer choices, eliminates actually it doesn't eliminate any of them. Oh no, it does. It eliminates the third one, the one that you had chosen, because one of your choices, I'm going to put here your third choice, the third answer choice in the picture that you sent me. It was y equals the square root of 4 minus x plus 5. This right here says it's going up 5, and by our graph, we can tell that it only went up 3, okay? So this here, that choice is not going to work. So this was our first choice, by the way. I'm going to put this as 1. That was our first choice. Now, so far, up 3 works on the first choice. Let me write the other 2 choices. The second choice was y equals 3 minus the square root of 6 minus 3x. And the fourth choice was y equals 3 minus the square root of 4 minus x. Okay, so here's that up 3. So 1, 2, and 4 are our only choices so far. Well, that's not going to help. Now we have to look for what says 4 to the right. Well, by looking at our choices, number 2 does not look like it's going to happen because of the way it's written. It doesn't even have a 4. So 1 and 4 are the choices that we're going to have. We're going to come back and talk about why 2 is not an answer algebraically, but just by common sense, 2 cannot be an answer because it doesn't have a 4. So now we're left with option number 1 and option number 4. Okay, so how do we go from there? They look kind of the same except for that negative, okay? So here's what's happening. So let's look at the first one. Y equals 4 minus x square root plus 3. So I always, always, always want to make sure when I'm looking for horizontal composition that the inside of my parentheses, or in this case, the inside of my radical, the coefficient of x has to be a positive 1. And right now, if you look, my coefficient of x is not a positive 1. So I cannot decipher what my horizontal shift is going to be with it being written like that. So I need to rewrite it to make my ability to say what the horizontal shift is by doing the following. So y equals, if I want my x to have a coefficient of 1, I need to get rid of that negative 1. So getting rid of stuff in high level algebra always requires us to most of the time factor. So I'm going to factor out a negative 1, or just a negative for that matter. Just factor out a negative, and I'm going to rewrite it. My x is going to become positive, and if I factor out a negative 1 out of 4, it's going to become a negative 4. And the plus 3 just comes down. So now I'm able, much easier, to tell what is happening as far as my horizontal movement. So based on this horizontal movement, now I can see, oh, okay, I can do the opposite of what's inside the parentheses. This here tells me, without the negative, by the way, so the parentheses x minus 4, I always do the opposite for my horizontal transformation. So x is going to be positive 4, because if you solve for x of that factor, so it is moving 4 to the right. That right there is a negative. It is not a negative outside of my parent function. It's inside my parent function, and it is originally belonging to my x. When it's located in this position, that means that there is a reflection over y-axis. If your negative had been, for instance, I'm going to make it purple out here.
I'm fine with that. If Shane, you want her just log as a
that would have been reflection over the x-axis, but that's not the case, okay? So ignore that. I'm going to erase it actually, okay? So that's reflection over the y-axis, okay. And this obviously is my up 3. So just by looking at this, these are all matching what this graph up here was supposed to be doing based on what we saw. So option 1 is my answer, okay? Going back to number 2, just to show you algebraically, we have y equals 3 minus square root of 6 minus 3x. We don't have an x value that has a coefficient of 1, so let's rewrite it. 3 minus square root, let's factor out a negative 3. So that's going to give me an x minus 2. And so what's happening here? All right, well, let's analyze this. This 3 right here, okay, just the 3, not the negative, says I'm going up 3. That negative tells me I am reflecting over the x-axis. This negative is telling me I'm reflecting over y-axis. I know this is really choked up. This 3 is telling me I'm having a vertical stretch by factor of 3. And what is this doing? It is going to the right 2. So that's how you algebraically justify why 2 was not an answer, okay? And where could we write number 4? Let's do it over here. What color should we do? Let's do it in orange. Let's do way over here. So for number 4, we have y equals 3 minus square root. So again, over here, number 4, we don't have coefficient of 1, so we want to factor out a negative 1. So I'm going to factor a negative and rewrite that as x minus 4. And again, I'm not going to write this out. I'm just going to say it. This is up 3. That here is reflect over the x-axis because it's outside. That's going to be reflect over the y-axis because it's inside with the x. When the x is outside of the entire function, it's reflection over the x-axis. This one here is reflection over the y-axis. And this tells me it went up 4. None of those matched what we had originally decided happened in our graph. So hopefully that is helping you understand a little bit more of what's going on. There is one other thing I wanted to review since I'm going to go ahead and send this to everybody. Let me go on to the next slide. We did not talk about this in yesterday's review, but if you go to text page 159, I'm just going to pick a problem. Let's look at number 14. And number 14 was f of x equals x minus 4 all squared. Okay, so if we look at this graph, we know it's a parabola, right? So let's graph it. So we know it's a parabola, and our parent function is actually, our parent function is actually g of x. Let's call it g of x. G of x equals x squared. So we can tell that this here is what has happened, and that has told us that our graph went to the right 4 units. Okay, so I'm going to go to the right 4 units. Let's call this positive 4, and we know nothing else happened, so our parabola looks like that. Okay, something like that. So if I right now were to talk about the domain of this graph, I would say that my domain is all real numbers, or I can say negative infinity to positive infinity. If I was talking about the range of this graph, I can say that it is going from 0 to positive infinity. Okay, now I know that by vertical line test, f of x is a function, okay? But by the horizontal line test, f of x is not 1-to-1. 1-to-1. Why? Because if I drew a horizontal line test, okay, it fails because it intersects more than once. So what can I do to the domain of this graph drawn in black? What can I do to this domain that would help this graph pass the horizontal line test? Well, I can easily do some removing of the parts. Well, like in the example given in number 14, they're saying find the domain on which the function is 1-to-1 and non-decreasing. Well, non-decreasing would be where? Well, if I trace the graph, here the graph is decreasing and then it starts increasing. So the non-decreasing part means the increasing part, and the only part that's increasing is from here to here. Okay, so what I'm going to do is I'm going to eliminate the part of the graph that I don't want, and that's going to be this part. So if I erase this part, all of a sudden now, my graph is going to pass the horizontal line test, and now it is only intersecting once. So the question was asking, find the domain on which the function is 1-to-1 and non-decreasing. Well, the domain is now going to be restricted to 4, positive infinity, where 4 is included and it goes on forever because we're basically saying to the right of 4. So I just wanted to talk about that too, since we did not talk about 1-to-1 yesterday. All right, that's it, my dears. Hope that helps.